Direct couple means it is between one stage of amplifier to another stage of amplifier is connected with a wire. Okay, so like in this example, let's take a look of the first stage. Okay, so I don't know whether you continue for this example or not from the previous class, but yeah, let's see. Okay, so for the first stage, Q1, okay, so the input, is so every time, okay, when you receive the question in the test later, also most BJT tests or okay, so you need to write down the terminal, okay, so that you won't be confused, okay. So the the figure might be drawn upside down, who knows, right? So you every time write down the terminal, okay. So it could be the emitter on the top and the collector on the bottom, in the bottom. So yeah, so let's write first the terminal. So we have base, collector and emitter at the stage 1. So the input at the stage 1 is, so when you have your Vs over here, which is the voltage supply, so your voltage supply here is connected to the base, and the output for the multi-stage will connected to the input of the output of the stage 1 will be connected to the input of the stage 2. Okay, so let's take a look at which terminal is connected between the two stages. So the terminal that connected between the two stages is collector. So this is the output of stage 1. Okay, so this is the input of stage 2. So in this case, all right. Okay, so in this case, so you have here what's left over here is emitter. Therefore, the first stage is common emitter. Okay, did you get the correct one? First stage is common emitter. Same like your answer?
Yes.
Hello?
Yes, okay.
Yes.
All right. Okay, so the first stage is common emitter. Okay, common emitter. So the second stage, the input part is the, so write down everything. So this is the emitter, this is the base, and this is collector. Okay, so the input is at emitter. Okay, where is the output? Okay, if you confuse, just look where the load resistance is. Okay, so load resistor always place at the output. Okay, so this is the output. Okay, so the output is at collector. So what's left over here is the base. Therefore, this is common base. Okay. All right. So did you get the same answer where the first stage is common emitter and the second stage is common base? Yes. All right. Okay. So let's derive it. Okay. So let's derive. So this is the example for the past year question actually. Okay. So it might look so difficult over here, but then when you draw the AC equivalent circuit, the capacitor is short circuit. Okay, capacitor is short circuit, then it will be much simpler. So let's derive or let's draw together the AC equivalent circuit. Okay. So for the AC equivalent circuit, so for this one, okay, so all capacitor is short circuit. Okay, capacitor short circuit. So this C1 short circuit, and also this C2 short circuit, C3 short circuit, and C4 short circuit. Okay, so all capacitor short circuit. Not to forget that the DC voltage also grounded. Okay. Okay, so you have one DC voltage over here and this is grounded. Okay, so let's draw the AC equivalent circuit. Okay, so the first stage is common emitter. So this is common emitter, and the second stage was common base. Okay, common base. Okay, so as of now, you already been very familiar how to draw the common emitter and the common base. Okay, so for the common emitter, so you have let's draw first, okay, for the common emitter. So look at here. So this is the base, okay, the collector and the emitter over here. So you have R pi, okay. Since this is NPN, okay, NPN, therefore you have plus minus V pi over here, and this is your base, okay. And you also have your GMV pi, okay, for the common emitter. So you have GMV pi, okay, and collector, and this is your emitter. Okay, so let's take a look at the emitter. Okay, what happened to the RE? Okay, what happened to the RE? Okay, you have is it bypass or unbypass RE? Okay, so look at here. So you have RE at emitter. You have RE. Okay, RE to the ground. Okay, and also you have capacitor, which is also from this node. Okay, you have RE. Okay, and for this node also you have capacitor, which is to the ground. Okay, to the ground. Therefore, RE and that capacitor C2 is in parallel. Okay, what happened to the RE in this case? Is it will be short circuited?
Yes.
Yes, okay, it will be short circuit. Okay, it will be short circuit because of this capacitor C2 is in parallel with it. Okay, therefore no RE in your common emitter AC equivalent circuit. Okay, therefore emitter will go straight to the ground. Okay, so let's finish it at the base. So at the base you have, okay, I've been drawing here like too many times. I hope that you won't be uh, uh, confused, okay, how to draw it. Okay, so at the base you have R1 to the ground, okay, and also you have R2 to the ground. Okay, so therefore R1 parallel with R2. Okay, what else at the base? You have C1 short circuit and also RS and VS. Okay, so this is your RS and this is your VS. All right, so from here, you will have your V in over here. So this is your V in 1 and this is your Z in 1. Okay, so look at the output, okay, of the stage 1 collector. So what do you have at the collector? Do you have any resistor at the collector? For the direct couple, like I said, you don't have any output resistor or input resistor, okay, or output resistor from stage 1 or input resistor from stage 2. No, okay. So it is a direct couple where collector connected to the second stage, okay. So second stage is a common base, okay, common base. So I hope up to now you already know how to draw the common base. So common base, you have R pi, okay, R pi. So this one, so what type of transistor for Q2? Is it NPN or PNP?
NPN.
MPN.
Are you sure? NPN?
Yes.
Yes, okay, so this is emitter, this is collector, and this is base. So when NPN, therefore your current flow is from collector to emitter. Therefore, your arrow of your GMV pi is from collector to emitter to the left. Okay, and also you have R pi over here. Okay, you have R pi over here. All right, so this is your base. Okay, okay, this is your base, and also you have V pi. Okay, and at collector, Okay, at collector over here. Okay, so let's take a look at the base. Okay, at the base. Okay, so since you have at the base, so actually the drawing is, we cannot expect that this is straight to the base. So you have something here at the base, okay, base, and also to the ground. So let's take a look at the base, okay, at the base, okay. So I forgot that we have another one DC ground, DC voltage here. That one will be grounded. Okay, so what happened to the, so at the base you have two resistor, as you can see over here. So you have R4 to the ground and also R3 to the ground. Basically, at the base, you have R4 and R3 in parallel. Okay, in parallel. However, at the base as well, you have C3. C3, and this C3 is short circuit to the ground. Means that C3 is in parallel with R3 and R4. Therefore, in this case, R3 and R4 also being short circuited. Therefore, RC and R4 has been short circuit, and you don't have to draw it in your circuit. Okay, therefore your base is straight to the ground. Okay, if let's say there is no capacitor C3 over there, therefore you have to put R3 and R4 in parallel at the base. Okay, at the base. All right, so you have here V pi 2 and R pi 2 and GMV pi 2. Okay, at collector, okay, at collector you have RC. Okay, RC, and also at collector you have RC and also RL. RL, okay, plus minus V out 2. Okay, plus minus V out 2. So previous class I just put VO2. Okay, all right, so you have Z in 1, and then you don't have Z out 1, okay, but you have Z in 2, okay, and you have Z out over here. All right, so that's it. Okay, all right, so the question said, okay, find the voltage gain and also the input and output impedance. So input impedance, you only have Z in 1. Okay, I need to copy for a while. Okay, so for the Z in 1, okay, what will be the Z in 1? Can someone tell me?
R1 parallel with R2
R1
parallel with
parallel
R5.
R2 parallel R pi.
Okay, so R pi 1 over here, VMB pi 1, GMV pi 1. Okay. So in this case, it is R1, okay, parallel with R2, parallel with R pi 1. Okay, so how about Z out? Z out. Common base. What is the Z out? It is very straightforward over there. What can you see from the output, from the Z out, from the arrow of Z out?
RC.
C parallel
Parallel with what? Not parallel with anything, you
CF
just see RC.
RC.
Yes, RC. Only RC. Okay, so you have Z in and also Z out. All right, so let's see what is okay, so let's see what is the V out 1 and also V out 2. Okay, so in here, okay, let me put a different color. Okay, so you have in here the V out 1 over here. 1 and also V in 2, right? So AV1 is equal to the V out 1 over V in 1. Okay, so what is V out 1? Okay, let's say I give you hint Z in 2 is R pi 2. Okay, so what is V out 1? Like I said, V out 1 is the voltage across that line, okay, from collector to the ground. Okay, it is in parallel with what? So what is the current at the V out 1? What is the
Negative
current?
GM by 1.
Yes, negative GM
Right.
V pi 1.
Z
What is the resistor across that V out 1?
Z
What are
in
the Z in 2? Okay, only Z in 2. Okay, so what is V in 1?
V by 1.
Correct. Okay, so you can cancel out here, therefore it is equal to the GM Z in 2. All right, so let's take a look on the AV2. So AV2, V out 2 over V in 2. Up to now, you already very much clear of it. Okay, so what is V out 2? What is the current across V out 2?
Negative GM V by 2.
Okay. Okay, what are the total resistor at the V out 2?
RC parallel with RL.
Yes. Okay, what is V in 2?
By 2.
Yep. Okay, so that's it.
Total
Yes.
for the common base one, the V pi 2 polarity is correct or wrong?
For the V pi 2 polarity, VBE, which current base ammeter. Wrong. It's wrong. Thank you. It is NPN. Therefore, where is the plus? Thank you. So where is plus? Yeah. Sorry about that. So you have VBE over here. Thank you. Okay. So you have this is your NPN. Okay, so V pi is actually replacing the VBE. So VBE at DC plus at the base, right? Plus at the base. Okay, so when you put it in your AC equivalent circuit, okay, so therefore plus VBE will become V pi in AC equivalent circuit. Therefore plus is at the base. Terbalik sorry. Thank you. So this is plus, this is minus. Can you understand this? Okay, plus, minus. Okay, terbalik. So this is minus. So this is plus. Okay, therefore your V in 2 over there, it will become what? So therefore V in 2 will be V in 2 will,
Negative V by 2.
yes, negative V pi. Okay, and negative delete it and it will be plus. Okay, GM RC parallel with RL. Okay, so for the AV total, okay, for the AV total, AV1 times AV2. If they ask you in dB, therefore you convert AV total in dB. Okay, means that 20 log AV1 times AV2, right? Okay, that's it. Okay, for the for this one. Okay, so for this example, I love you with this. I don't know whether you try it or not, but this is how you derive it. Okay, for this direct couple amplifier between common emitter to common base. Okay, So that's it for this one. Okay. I want to start with the tutorial. MOSFET, do you have any question? All right. So I will stop this recording because I will start a new recording.